Okay, question 5. We've got a speed time graph of two guys walking. They're walking at different rates for 9 seconds, and we're asked to find their distance in the form of a ratio m to n. And we're told that m and n are double-digit integers. Well, let's first of all work out the distances of these two guys. Okay, dealing with man 1 first. He's got 3 areas of his journey here. Remember, the area under a speed time graph is the distance. So this will be distance 1, distance 2, distance 3, and we have to add them all up. So the area of distance 1 is half the base times the height. Half of 2 is 1, multiplied by 4, works out to be 4. Distance 2. Down below here is 1, 2, 3, 4. 4 times 4. So this is 4 times 4, 16. Distance 3. Distance 3 is a trapezium. The vertical heights are 4 and 6. We add 4 and 6 and divide them by 2 to find the average of the parallel sides of the trapezium. And we have to multiply that by the distance between the two parallel lines, which is 3. 4 plus 6. 10 divided by 2, that's 5. 5 times 3, so this is equal to 15. Adding these up, 15 and 16 and 4, this is 35. Now for M2, there are only 2 distances to worry about. This distance here, which is the triangle, and this distance here, which is the rectangle. The triangle first, half the base times the height. 5 times 5, 25, divided by 2, which is equal to 12.5. And now distance to the rectangle, 5 height, and the width is 4. So this is 5 times 4, which is equal to 20. So adding those up, we get 32.5. The question asks us for the ratio of M1 to M2, the distance they both travel, and we've got an answer of 35 to 32.5. We're not going to get full marks of that because we've not complied with their requirement that m and n are double-digit integers. We can multiply this ratio by 2, and this becomes 70 to 65. Well, those are double-digit integers, but they're not simplified because we can take a factor of 5 out of both of them. So dividing both sides by 5, we get 14 to 13. And that you'll find is the answer.